Hello and welcome friends. In this particular module, we wish to discuss about the permanent adjustments of tilting, automatic and digital level used in leveling or land surveying. The relevant background has been discussed through two presentations in which we have discussed about vertical distance measurement and permanent adjustment of dumpy level. The concept that we have discussed in that modules will be helpful to understand the concept that we are going to discuss in this module. Here we'll have again just review over the desired relationship among the fundamental axes of the level, and essentially we'll discuss about the test to be performed and permanent adjustment to be done for tilting, auto as well as digital level. As you learn this particular content, you will be able to define the permanent adjustment and state the essentiality of the same for tilting, auto and digital level. You will also be able to carry out the test to assess the desired relationship among the fundamental axes of the tilting, auto as well as digital level, and you will also be able to carry out permanent adjustments of tilting and auto level. As we discussed in the last presentation, every leveling equipment has three axes: vertical axis, about which the equipment rotates in the horizontal plane; axis of level tube, which we refer to in order to make the line of sight horizontal; and third one is the line of sight, which we refer to take the star readings. In properly adjusted level, the axis of level tube should be perpendicular to the vertical axis. Horizontal crosshair should lie in a plane perpendicular to the vertical axis. The line of sight should be parallel to axis of level tube. Also, the axis of telescope and the line of sight will be overlapping each other. In this particular presentation, we will be discussing about the tilting level, auto level and digital level. According to the type of level, there may not be necessity of the forced adjustment, but for all the category of the levels, we do need the crosshair to be placed in horizontal plane. Hence, this particular test could be performed and accordingly the adjustment could be done the way we have discussed about the dumpy level. However, whatever may be the kind of the level and whatever may be the type of level tube that we deal with, the line of sight going to be defined by taking the reference of that particular level tube should always be in the horizontal plane. Hence, this adjustment is valid for all the category of the levels. As we do the permanent adjustment, if the equipment is properly handled, the relationship that we establish will last longer. So, It's better to ensure that the instrument is in perfect adjustment before carrying any leveling work. We must assess that the desired relationship among the axes is established after carrying out the temporary adjustments. Moreover, whenever we procure the equipment from any supplier, generally the equipment is available in perfect condition. However, because of its continuous usage, wear and tear, and the loose fittings, or the major reason could be mishandling, the equipment may be out of adjustment, and hence we have to provide periodic check for all the category of the levels that we use for leveling work. Let's try to understand about the permanent adjustment of this particular tilting level. So in case of tilting level, it is not essential that the vertical axis of the instrument should be truly vertical. The way we discussed about the dumpy level, this is kind of time saver. However, according to the construction feature of this particular tilting level, we will be making use of tilting screw in order to bring the bubble at the center of its run prior to taking each reading. Hence, we need not have the first adjustment as far as tilting level is concerned. The second fundamental relationship could be tested and be adjusted. Now, the third fundamental relationship needs to be tested the way we discussed earlier. That is, we can go for some two-peg method, and accordingly we can work out the error and hence the required true reading at the stop, which is placed at further 8 from the equipment position. As far as this particular adjustment is concerned, we have to follow some modifications after step 3 that has been discussed in earlier presentation. So, after working out the true reading at the farthest station, rotate the tilting screw and make the line of sight passing through the calculated correct stop reading. As the line of sight gives the calculated correct reading at this particular distance stop, then the bubble is to be brought at the center of its run by making use of capstan headed screws that are provided for that particular level. This particular test, step 4 and step 5, needs to be repeated till the bubble remains centered when the stop reading is maintained as it is. Please note that in case of the dumpy level, after determining the error component and after determining the true reading, we had adjusted the diaphragm by making use of the adjustment screws provided on the circumference of that particular diaphragm ring. But in case of tilting level, we are not touching that particular diaphragm, but we are bringing the bubble at the center by using the capstan headed screws provided at the bubble tube. Now, let's try to understand the permanent adjustment of auto level. As the construction features related with this particular auto level are discussed in earlier presentations. You know that the telescope is similar. We are provided with the eyepiece, we are provided with the object glass. But here now we do not have the longitudinal level tube, but we have this particular circular bubble tube, or it is also called as pond level. So this particular pond level initially we use in order to level the equipment, whereas focusing of the eyepiece and focusing of the object glass is very similar to the way we do it in case of dumpy level. Now here, initially we bring this particular bubble approximately at the center of this particular circle, or we make it lying within this particular circle. Thereby, the bubble will be giving us the vertical axis of the equipment, making some inclination of 15 to 30 minutes. As the verticality of the equipment is brought to this particular inclinity of 15 to 30 minutes with respect to the vertical axis, now the compensator that is provided inside the body of this particular telescope will be active, and accordingly here the assembly of fixed prisms and this particular suspender will make the line of sight horizontal even if it is slightly tilted. This is nothing but the construction principle as far as auto level is concerned. Hence, initially we should know about the position of the bubble, hence the adjustment related with this particular circular bubble tube. We should know about this particular compensator, and then we can go for the adjustment of line of sight. As far as this auto level is concerned, principally the adjustments are similar, but according to the manufacturer there may be slight variation. Hence, every equipment is usually provided with the instruction manual and better be referred while carrying out any of such permanent adjustments. So the first thing that we wish to do is working of the compensator. So to check this, we can keep the stop about 30 meters away from the equipment. After centering the position of the bubble, we can slightly tap one of the legs of the tripod using our hand. So the horizontal head could be giving certain stop reading. So that particular reading will appear to swing in the field of vision, but it will return to its original reading immediately. Even we can have the leveling screw turn through small division so that the line of sight will be slightly inclined. As you know, if the line of sight is slightly tilted in case of auto level, it will be made horizontal automatically by using that particular compensator assembly. So, as the stop reading appear to swing and as it returns to its original reading, it indicates that the compensator is in adjustment. If any of these two methods does not help, and if the original reading that is available on the stop is not returned to, the adjustment needs to be done. As discussed previously, we can make use of the manual that is provided with the equipment in order to adjust this particular compensator, but uh, I have a feeling that this particular compensator is the part of the essential part of that particular telescope. It needs to be opened and accordingly here it needs to be adjusted. Hence, there could be certain say servicing centers related with that particular auto level and hence such servicing centers may be contacted to perform this particular permanent adjustment. The pond level can be tested the way we thought about the dumpy level. That is, we can bring the bubble at the center of the run by making use of leveling screw. Here, usually for auto level, we need not have the telescope resting on any two foot screws and turning the same end to end. Just make use of two leveling screws. Bring the bubble at the middle of its run. Make use of remaining screw. Turn it so as to have the bubble shifted at the center of the engraved rig. Now, as we turn the telescope through 180 degrees, the position of the bubble should remain center. Now, here it is quite probable that bubble could be shifted through some small divisions, but still it could be lying in this particular engraved circle. So, if it is so, we can assume that the given position is indicating the level is in level condition. However, if the bubble is shifted the way I have shown here, we have to perform the adjustment. Now, this particular movement of the bubble could be because of the tilt that is involved with respect to horizontal plane. And hence, this particular tilt needs to be adjusted by removing the half of this particular horizontal component of displacement using appropriate leveling foot screw and then removing the remaining half by adjusting the base of the level by making use of the level adjusting screw. The vertical component of that particular displacement is then removed by leveling screw and the remainder is compensated using the level adjusting screws. Here, this particular say adjustment can be done through the instruction that are given in the manual. So here we just discussed about that first two steps. Now here the way you see step 3 compensate for one half of the shift by adjusting the leveling foot screw. So here as you see this is the position of the bubble. Now make use of leveling screw. Bring the bubble through half of its run. Then remaining half is to be shifted using the hexagonal range that is provided with the equipment. So here this particular manual is of Sokia company. So here you can refer some such steps in order to follow the particular adjustment. Here also you can see the automatic compensator test the way we discussed on earlier slide. In order to have the third adjustment, we can follow the similar method. Here the way you see there are two pegs placed at equidistance from equipment position. As such, here this A1 minus B1 will give us true difference in elevation. Now, As we keep the equipment very close to station A, the way it is mentioned here to be some 2 meters, so accordingly the reading obtained A2 will be unaffected because of the probable tilt of that particular line of sight. Hence, the true reading at station B can be worked out as the observed reading minus the true difference in elevation that is worked out in the first setup. So here if this particular V2 dash is same as that of the observed reading, the horizontal cross line is in normal condition and adjustment is not necessary. However, if they are different, we have to adjust the horizontal hair. So in order to adjust that particular horizontal hair, open the eyepiece end, you will get the some such view. So herein you can see there is a provision of capstan headed screw at the upper end, whereas its lower end is spring loaded. So according to the requirement, we can make use of that particular range, and accordingly here we can turn the capstan headed screw in order to have the vertical movement of this particular diaphragm. So as we have the vertical movement, the horizontal hair could be placed in order to have the calculated correct reading. So here the procedure that we follow for the dumpy level is almost same as we expect to follow for the permanent adjustment to make the line of sight horizontal for automatic level also. Now, in case of digital level, we have to follow the manual instructions. So here we are referring to Leica Sprinter manual. Just see the steps as they have given. First step tells us with the level set up at the midpoint, activate the check and adjust program by pressing menu adjustment. Should display cryptic instruction like adjust 1/4 with an arrow labeled measure pointing back to the rod. As you know, in case of digital level, we make use of the pond level very similar to the auto level, and we ensure the line of sight horizontal by making use of inbuilt compensator, again very similar to the auto level. So here just we have to press measure button in order to take the staff reading. As we take the staff reading, it will be automatically recorded in the memory of this particular equipment, as well as it will also reflect the distance of the staff station from the instrument station. As such, we need not enter any reading in the field book, as well as we need not calculate the reduced level. So here that particular reduced level is automatically computed, distance is automatically computed, and it will be saved in the memory of the equipment. So here we need not go for any manual adjustment except the measure key. So here in the step 2 now, aim the rod at A and press the measure key. Measurement will be displayed. Press enter key to accept or to confirm the readings. Now aim at station B. Again press the measure key, which is nothing but step 2/4. The measurement displays. Press enter to accept and confirm. So here the way we discussed for all the category of the levels, the steps 1, 2, 3 are very similar to the equipment setup established in between the two stop stations at its midway. Now, shift the level towards rod A about 3 meter away and make the reading to B again. So, this will be adjustment reading, which is step third out of fourth steps. Aim at rod A and press measure. So, here the measurement displays, press enter to accept or confirm. The new collimation error is displayed in seconds of angle and corresponding DH vertical error in millimeter at that particular distance. So to accept the correction, now press the enter key. So here whatever things that we were doing manually in case of all the other levels, it is being done through the inbuilt program for that particular digital level. Further, if this particular reticular adjustment is required, now reverse the stop B for the E scale bar reading, then adjust the reticle using the tool provided by following through the given instructions. In the event where warning message, for example, invalid measurement is displayed for any adjustment measurement, carry on measuring until successful measurement is obtained and press enter key to accept that particular measurement. If we wish to quit that adjustment program, we can press that particular escape key once. The display will go to last adjustment step. As we press this particular escape key twice, the display will return to the menu, and as we press this particular escape key successively thrice, the display will be coming to default measuring mode. In some category of the digital levels, we can perform this particular adjustment in the very similar manner the way we discussed about the auto level. That is, we have to open this particular eyepiece end. You will find that particular spring loaded diaphragm. You will find the capstan headed screw. You have the range with you. So only the thing is that we won't be measuring that particular distance by using bar coded stop, but it's reverse side, and we can make use of that E scale bar so as to have the stop readings adjusted manually. So thank you for your attention. I hope the concepts that we have discussed are clear to you. In the next presentation, I wish to discuss now about the contouring in land surveying. So bye till then, I wish you very happy learning. Thank you very much.